we can come up with a neat little expression for the average velocity of an object between two events when it's moving under constant acceleration. We have our three constant acceleration equations right here. Let's use a couple of them here to come up with our expression. All right, so by definition, the average velocity between two events is given by the change in the position, that is to say the displacement between the two events, divided by the time interval between the two events. Okay, well, the displacement is given by this expression right here if the object is moving under constant acceleration. So for my numerator, I can replace delta x with everything on the right-hand side of this equation. So my numerator becomes v1 delta t plus 1/2 a delta t squared, and my denominator is still delta t. Okay, I can cancel out some things here. Delta t right there on top, cancel delta t on bottom, and this delta t squared, one of those delta t's cancels out with that delta t on bottom, so I can drop the squared right there, and rewrite this as v average equals, that's just v1 left there, plus 1/2, and this is a times delta t left there. All right, now using the first kinematics equation for constant acceleration, a times delta t, that can be replaced by delta v. So I've got here v1 plus 1/2 delta v. I'll expand delta v out. It's of course v final minus v initial. I'll call it v2 minus v1. So v1, that's our v initial, plus 1/2 v2 minus v1. All right, well, here's 1 v1 minus 1/2 v1 gives us 1/2 v1's remaining plus 1/2 v2. Half v1 plus half v2. So this is equal to our average velocity. There's our answer basically. Let me rewrite it over here as v average equals, I can rewrite this as v1 plus v2 divided by 2. There we go. We add the two velocities, the final and the initial, and divide by 2. That tells us the average velocity over that time interval. It's the simplest sort of situation in which we can find an average velocity. And you probably could have predicted this. If you have an object moving at constant velocity, its velocity versus time graph is, of course, linear. So between events 1 and 2, there's its initial velocity, there's its final velocity. Just from looking at the graph, you could convince yourself that the average velocity has to be exactly halfway in between the two. There's your average velocity right there. Halfway in between.